Hi, and welcome to this quick introduction to container technologies. My name is Carl Moberg. I am the CTO and one of the co-founders here at Avassa. The reason I put this brief video together was because people have asked me many times what container applications are, how they compare to virtual machines, and how container applications work at the edge. So this is my attempt to give you a quick answer to those questions. And I know that answers like these ones usually leads to additional questions. So please reach out to me if you have any additional questions or just want to chat about any of these topics. Okay, so I usually talk about containers as a way of addressing a problem that the industry has been struggling with kind of since computers were born. And that is how to package an application, that's a computer program, in a way that you can reliably run it anywhere. Now, historically, each type of operating system and even versions of the same type of operating system has required different ways of packaging applications. If you wanted to package an application so that it worked, for example, for Red Hat Linux and for Ubuntu Linux out of the box, you had to actually create one package for each target operating system because they both have different packaging frameworks and different ways of installing and updating applications. And the same obviously goes for other operating systems, including Windows. So by shipping your application now as a container application, you will be able to run your application anywhere, independent of which operating system flavor is running on the computer. And this goes all the way from how developers run their applications that they're developing on the laptop to the production environments where vendors want to run their applications. And this avoids a huge amount of costly and time-consuming mistakes and delays in that process. And this is, of course, where the name comes from. It's a standard packaging format that's universal and provides the same kind of general universality as, of course, freight containers do in the shipping industry. They can be moved from vessel to vessel, independent of or from what's in them, as long as they adhere to the same physical sized standard. So how are containers different from virtual machines then? Well, if you remember, I said that containers package applications. Virtual machines, or VMs, on the other hand, is a way of packaging entire operating systems and all applications installed on them. So a VM image is an executable file that includes an entire operating system, and you run a VM on a hypervisor that emulates the hardware. So when the VM has booted, it has become an instance of a guest operating system on the hypervisor. And of course, if you run several VMs on the same hypervisor, you end up with several instances of operating systems, including their applications. So that is all good and well if what you want to do is to ship a full operating system with applications, and when boot times and the size of the VM image is not a problem. But if you're looking to ship an application, containers are much more fit for purpose. So a container image is literally an archive file containing the application and all required dependencies. And you run an image on a container runtime that knows how to set up the operating system to host it in its own little sandbox and start the application. And this makes it into a running container. And of course, if you want to run many containers on the same host, you simply run several images, and the container runtime makes sure to keep them isolated from each other. So this avoids the significant overhead of managing instances of operating systems per application, both in terms of the resources consumed on the host, but also the size of the files. So you can see how this application-centric packaging format is far more efficient than VMs. So what makes containers great for the edge then? Well, first of all, most edge scenarios are defined by limited compute resources in each of the edge sites. You simply don't have the same amount of computers as you have in central data centers. So requiring less compute resources per application, including smaller file sizes, becomes very important. The second part is, of course, the universal nature of the format. I mentioned that by packaging applications as containers, you can run them anywhere, and that includes edge environments. As container runtimes are becoming more common, even in scaled-down environments, the opportunity to run the same containers there as in the cloud becomes more valuable. And lastly, since many enterprises have already settled on containers as the universal packaging format, they can get full reuse of the tools they already have in place for development and testing, and this allows them to integrate the edge with their existing cloud processes and tools. And with that, thanks for listening, and hope this provided a useful overview of container technologies. and how they work really well for the edge. If you have any questions, please feel free to reach out directly to me, and I'll be happy to help in any way that I can.